Hello everyone, my name is Yuchao Zhang, and my topic is Analysis of Inversion Control and Aspect-Oriented Programming in Spring. Here is the agenda. The first part is Introduction. The second part is Inversion Control, which is as known as IOC. The third part is Spring IOC. The fourth part is Aspect-Oriented Programming, which is as known as AOP. And the fifth part is Spring AOP. Here is the introduction. The widespread use of J2EE began in 1999 and 2000, and its emergence led to the standardization of core middle-tier concepts such as transaction management. But in practice, J2EE has not been absolutely successful because development efficiency, development excellence, and actual performance are disappointing. Developers using EJBs need to strictly implement a variety of different types of interfaces, which makes a lot of similar or repetitive code. The configuration is also complex and monotonous, as well as using JNDI. Although some shortcomings have been elevated with the emergence of X.let, the high cost of using EJB and the extremely low development efficiency and high resource consumption have made EJB difficult to use. To solve these problems, Ruth Johnson created Spring Framework. The framework was first released under the Apache 2.0 license in June 2003. Compared to EJB, Spring is a lightweight framework. Here are some main differences between Spring and EJB. At transaction management aspect, Spring supports multiple transactions such as GTA, Hibernate, JDO, and JDBC. EJB only supports JTA. At dependency injection aspect, Spring supports list, properties, map, and Java naming and directory interface resources. EJB can inject EJB data, JMS resources, JPA resources. At AOP aspect, Spring supports Aspect-J and Spring AOP. EJB only provides limited support through interceptors. Here is the structure of Spring. As we can see from the picture, the IOC container is the core of Spring, and AOP is based on it. So this part is inversion control. What is inversion control? Inversion control is a principle in software engineering by which the control of objects or portions of a program is transferred to a container or framework. It's most often used in context of object-oriented programming. Why do we need inversion control? Inversion control is proposed to achieve decoupling requirements in software development. Specifically, its goal is to reduce the dependencies between models and make each model relatively independent, allowing developers of each model to focus on developing and maintaining their own models. Inversion control can be achieved through various mechanisms such as strategy design pattern, service locator pattern, factory pattern, and dependency injection. What is dependency injection? In a program, the operation of one model may require the use of other models. This is called dependency. Dependency injection means that the model no longer creates the object of models it needs. The container or the framework will create them and inject into it. Here is the picture shows the relationship between class and the dependency injection. When the class needs some objects, dependency injection creates them and gives this object to the class. There are basically three types of dependency injection. Constructor injection. The dependencies are provided through a class constructor. Setter injection. The client exposes a setter method that the injector uses to inject the dependency. Interface injection. Dependency provides an injector method that will inject the dependency into any client path to it. Clients must implement an interface that exposes a setter method that accepts the dependency. This part is Spring IOC. The Spring IOC container is at the core of Spring Framework. The container will create the objects, wire them together, configure them, and manage their completely life cycle from creation to destruction. The Spring IOC container uses dependency injection to manage the components that make up an application. The following diagram is a high-level view of how Spring works. The application classes are combined with configuration. Developers only need to provide the objects and the configuration to the Spring container, and the container will produce a fully configured system, which is ready for use. These two packages are the basis for Spring Framework's IOC container. The Bean Factory interfaces provides an advanced configuration mechanism capable of managing any type of object. Application context is a sub-interface of Bean Factory. The configuration metadata is represented in XML, Java annotations, or Java code. Here is an example of Spring IOC. Here, I create a class named PersonInfo. It includes two attributes, name and age, and their getter and setter methods. Here is the interface, which includes a sayHello method. Here is a concrete class, which implements the interface above. And the sayHello method outputs the name and age of the PersonInfo. Here is the configuration file. In this file, I configure two objects. The Spring IOC will create them, and I use a setter injection. Here is the test class. In the test class, I create the IOC container, get the object from the container, and execute the sayHello method. This is the screenshot of the result. As you can see from the picture, the sayHello method outputs the name and the age which are injected into it. Let's talk about the advantages of Spring IOC. Decoupling the execution of a task from its implementation, making it easier to switch between different implementations. Greater modularity of a program. Greater ease in testing a program by isolating a component or mocking its dependencies and allowing components to communicate through contractors. The next part is aspect-oriented programming, which is known as AOP. Before talking about AOP, I want to discuss object-oriented programming. In OOP, there are three main principles: encapsulation, inheritance, and polymorphism. Both the second and the third one focus on the vertical relationships between classes. But how about the horizontal relationship? Here is an example. Withdraw, check balance, and deposit are the most common services in the bank system. Before these services, the system needs to do the verification, and after these services, the system needs to do the logging. Verification and logging are called cross-cutting concerns. In AOP, a feature like matrix is called a cross-cutting concern, as its behavior that cuts across the multiple points in the project models. It is distinctly different. As a development methodology, OOP recommends that developers abstract and encapsulate cross-cutting concerns. In AOP, there are several main concepts: join point, a point during the execution of a program, such as execution of a method or the handling of an exception. Otherwise, action taken by an aspect at a particular join point. Point cut, a predicate that matches the join point. Otherwise, it's associated with a point cut expression and runs at any join point matched by the point cut. For example, the execution of a method with a certain name. Here is the relationship between them. As you can see from the picture, the aspect include advice and point cut. There are many implementations of AOP, such as JBoss AOP, Aspect G. The following describes Spring AOP. Spring AOP is based on Spring IOC container, unlike Aspect G and JBoss AOP, which provide attribute-level join points. Spring AOP only provides method-level join points. In Spring AOP, there are 5 kinds of advice. Before advice that executes before a join point, but which does not have the ability to prevent execution flow proceeding to the join point, unless it throws an exception. After returning advice to be executed after a join point completes normally. For example, if a method returned without throwing an exception. After throwing advice to be executed if a method exits by throwing an exception. After or finally advice to be executed regardless of means by which a join point exits, normal or exceptional return. Around advice that surrounds a join point, such as a method invocation. This is the most powerful kind of advice. Around advice can perform custom behavior before and after the method invocation. It's also responsible for choosing whether to proceed the join point or to shortcut the advice method execution by returning its own value or throwing an exception. It should be noted that only one of after returning and after throwing advice will be executed. Here is an example of Spring AOP. First, I create an interface, which includes the sayHello method. Then I create a concrete class, which implements the interface above. As you can see from the screenshots, the sayHello method outputs the hello. Here is the logger class. There are 3 methods. Here is the configuration file. In this configuration file, I configure the specifically point cut and 3 kind of advices, which are before advice, after returning advice, and after advice. Here is the test class. First of all, I create a Spring IOC container based on the configuration file, and I get an object from the container and execute its sayHello method. As you can see from the result, both before advice, after returning advice, and after advice all be executed. Let's talk about advantages of Spring AOP. Spring AOP is non-invasive. Service or domain classes can get advice by the aspect without adding Spring AOP related class or interfaces into the service or domain classes, and it allows the developers to concentrate on the business logic instead of cross-cutting concerns. Spring AOP is implemented in pure Java. There is no need for a special compilation unit or special class loader. It uses Spring IOC container for dependency injection, Aspects can be configured as normal sprawling things, like any other AOP framework. It weaves cross-cutting concerns into the classes without making a call to the cross-cutting concerns from those classes. It centralizes or modularizes the cross-cutting concerns. It's easy to maintain and make changes to the aspect, and changes only to be made in one place. Provision to create aspects using schema-based or annotation-based style, and it's easy to configure. Thanks for watching.